Algebra. Here are the notes that I didn't get to from yesterday. So I'm on page 14 and we have the position equation is given. So if you are going to project something, we have this formula here. So S is the height of the object at any given time. T is the time. V of O, which is that one right there, is the initial velocity. We have SO, the initial height of the object. So I'm going to drop a ball from the top of some building, which is about 168 feet tall. So I am talking about the initial height of the object. So that one is your initial height. Velocity, it's like how much, I don't know, how much energy you have. Like when you hit a bat, when you hit a ball with a baseball bat, there is velocity from it coming off the bat. However, you are going to just drop the ball. So if you're going to drop it, I know there's no velocity there. Use this equation to write a mathematical model. All right. So S equals negative 116 t squared. There's no velocity, and my initial feet is that SO, and that is 168. All right, so I wrote my equation. B, find the height after 2.5 seconds. So T equals 2.5, and S means height. So into this formula right here, I'm going to plug 2.5 in for T. I'm going to run the numbers, and I get 68. So at 2.5 seconds, it is 68 feet in the air still. C says, how long does it take to hit the ground? The height of the ground is 0, and the height is S in our formula. So in our formula, S equals negative 16t squared plus 168. So I'm going to set S equal to 0. And I'm going to solve for T. And I have many, many options here. You could run the quadratic formula. You probably don't want to factor it. But I do just have a squared and a plain old number. I'm going to send the t squared term to the other side. So I have 16t squared equals 168. My plan here is that I'm going to eventually solve by square root. If you would like to take the square root, you have to get your variable by itself. So your next move is to divide both sides by 16. I have t squared equals 10.5. Now I'm going to solve for t by taking the square root of both sides. So t equals plus or minus 3.24 seconds. Well, in this case, a negative time would not be reasonable. Up in the instructions, it said round it to 1 decimal place. And so therefore, it took 3.2 seconds for the ball to land. The next one is imaginary numbers. So at some point in time, we've said you can't take the square root of a negative number. Like if you try to put -5 in your calculator, it will give you a domain error. But they've decided that in order to work with them, we are going to write this as an imaginary number. So if you have a negative under the radical sign, you can rewrite that as the square root of -1. A complex number is an expression that contains a real number and an imaginary number. So in standard form, it would look like a plus bi. So if you have a variable, in many ways, it's just like having an x, a y, any variable. So you can still combine like terms and do all your normal algebra up until the end. So here I have these terms that I would like to add. The parentheses are not important because I'm just adding them. So I'm just going to drop the parentheses. And now I'm going to combine like terms. So -5 plus 4, those are my constants. Those are like terms. If you are a person who needs to rewrite them and group them together, you can. The 7i and the 9i are like terms. So when I combine my constants, they add up to -1. And when I combine my i's, they add up to 16i. So there's your good final answer on that. When you have a subtraction sign between them, you have to distribute the negative. So I have -3 plus 8i minus 2 minus 3i. My constants come first, so I'm going to add -3 and -2, and that adds up to -5. I'm going to add my i's. 8 minus 3 adds up to 5i. This is a big multiplication problem. So I have -2 times I times 7 times I. I'm going to rewrite it, and I'm going to put the numbers together, and I'm going to put the letters together. So when I take -2 times 7, I get -14. And then when I take I times I get I squared. All right, we should learn what I squared is. So if you were to square both sides right there, the exponent cancels out that, and so I squared equals -1. This is a common substitution that we are going to use. So I have -14. Instead of I squared, I'm going to sub in -1. Negative times a negative equals +14. Number 4, I'm going to multiply, distribute, FOIL. -2 times 8 is -16. -2 times -i is a +2i. 6i times 8 is 48i. And 6i times -i is -6i squared. All right, I have several things that I need to do. The first thing is I need to combine like terms. They add up to 50. The other thing that I'm going to do is I'm going to replace my I squared with -1. So once again, anytime I see an I squared, I'm going to substitute -1. So I have -6 times -1. -16 plus 50i, a negative times a negative equals a +6. Now I have these two constant terms that I'm going to combine. They add up to negative 10. Plus 50i is your good final answer on that one. All right, so on this one, this says that I equals the square root of negative 1. I would highly recommend that if you have a negative under the radical, that you take care of these square roots and turn them into i's before you distribute, because I think it makes it way easier. The other thing that why you really have to do that, so if you were thinking of taking the square root of negative 36 times the square root of negative 9. So in normal words, you might say that a negative times negative is a positive. But there's this caveat. If you cannot take the square root of the number as is, then when you multiply it, you still can't do it. So we're going to replace them with I first. So I have 3 minus. So 36 is a perfect square. The square root of 36 is 6. And then the square root of the negative portion right there is I. Right here, the square root of the 9 portion is 3, and the square root of the negative portion is I. Now I'm going to multiply and distribute these. So 3 times 2 is 6. 3 times 3i is 9i. Negative 6i times 2 is negative 12i. Negative 6i times 3i, negative 18i squared. I'm going to combine like terms. Oops, that's minus, sorry. Minus 3i. Now, the other thing that I'm going to do is I'm going to substitute right there. Anytime you see an I squared, you sub in negative 1. So I have 6 minus 3i. A negative times negative turns that into a plus 18. And 6 and 18 add up to 24. And that is your good final answer. On this one, so you have a squared here. So the first thing that I would do is I would rewrite this as 2 plus 5i, 2 plus 5i. It really makes no difference if you distribute the 7i into here or if you save that and you distribute the parentheses first. But you absolutely cannot distribute the 7i into an expression that is being squared, because then you will have violated order of operations. All right, so I'm going to multiply. 2 times 2 is 4. 2 times 5 is 10i. 5i times 2 is 10i. 5i times 5i is 25i squared. It would be best if you would combine like terms and deal with that I squared before you go distribute the 7i. That adds up to 20i, and that is going to be a negative 1, and a positive times a negative. I'm going to end up with a negative 25 right there. I would probably also combine like terms before I distribute that. So that adds up to negative 21 plus 20i. Now I would distribute that, and that gives me negative 147i. That gives me 7 times 2 is 14, 140i squared. When you see an I squared, you're going to replace that with a negative 1. So now I have 140 times negative 1, which gives me negative 140 minus 147i. So then I just switched places so that I put it in the correct order. We talked about conjugates yesterday before we left, and if you are dividing complex numbers, you will multiply the top and bottom by the complex conjugate. So the conjugate is the same, you just change the sign. So if you have a plus bi, then a minus bi is going to be its conjugate. So conjugates are the same thing, but different signs, like 2 plus 3i and 2 minus 3i. Those are conjugates. So it's all about the sign between them. It has zero to do with the sign out in front. So don't change that 2 or anything. That would be bad. I have a few more back here. All right, so I just have a single term. A single term doesn't have, it's not necessary to multiply by a conjugate. A conjugate is only when there's 2 terms. So I would like the I out of the denominator, so I'm going to multiply the top and bottom by 3i. You already have 2 terms, so you need to know that there are parentheses around that. And so you are going to have to multiply and distribute every term on top to the 3i. 8 times 3i is 24i. Multiply those and you get 15i squared. You multiply those and you get 9i squared. So once again, I squared equals -1. So wherever you see an I squared, now I'm going to go plug in -1. 24i plus 15 times -1 divided by 9 times -1. So I have 24i minus 15 divided by -9. So when I look at these numbers, I see a 3 that's common to all of them. So I'm going to divide all 3 numbers by 3. 24 divided by 3 is 8. 15 divided by 3 gives me -5. -9 divided by 3 gives me -3. I would probably go change the order, so -5 plus 8i divided by -3. Just in case you don't see the negative there in the answer, it is completely possible that they have then multiplied both the top and bottom by -1. I mean, I think this is a perfectly fine answer, but if you are on a multiple choice and you don't see anything like this, then you might need to multiply every term by -1. So this would be the same thing as 5 minus 8i divided by 3. On number 8, I'm going to multiply by the conjugate of the denominator, which is 5 minus 2i. We have 2 terms on top and bottom, so you need to know that there are parentheses around that. So I'm going to FOIL the top, I'm going to FOIL the bottom. 3 times 5 is 15. 3 times -2 is -6i. -2i times 5 is -10i. -2i times -2i is plus 4i squared. FOIL the bottom. That gets me a 25. 5 times -2 is -10i. 2 times 5 is plus 10i. 2i times -2i is -4i squared. What should definitely happen is on the bottom, those 2 like terms definitely cancel each other out. My plan is to combine like terms in the numerator and sub in -1 for I squared. Sorry, the school bell just rang. We're on a shortened schedule. I have 15 minus 16i plus 4 times -1 divided by 25 minus 4 times -1. I'm going to hit the pause button and jump to the answer in a minute. All right, so you can see I I finished combining like terms, and there's my good final answer. So when you have an I to the first is I. So we have this pattern. I squared equals -1. Yep, we've been doing that. I to the third would be the same thing as I squared times I. I squared is -1, and so when you multiply those, you get -I. If you had I to the fourth, that would be the same thing as I squared times I squared. So they subbed in. They each equal -1, and so when you multiply, you get 1. If you have I to the fifth, so we just found that I to the fourth is 1, and so we seem to have a cycle. So every 4, it cycles back to the first one. So this shows the pattern for powers of I in groups of 4, and then it just repeats. So because of this, we can simplify very large exponents here. So to do that, we're going to take your exponent and we are going to divide it by 4. So I have 33 divided by 4, which is 8, remainder 1. So it's all about what the remainder is. So if you have a remainder 1, that means you would have I to the first power, which is I. So if you took this and you ran through this cycle 33 times, you would end back at I. So you're taking your exponents divided by 4 for these. 4 goes into 47 11 times with 3 left over. And so whatever your remainder is, that's the cycle that it's on. So I to the third means that that simplifies to -I. And then if you have I to the -16th, so I have -16 divided by 4, which is -4. So I have I to the -4. So you fix negative exponents by sending them to the denominator and turning it into a fraction. So I would write that as 1 over I to the 4th. So up here, 4 I to the 4th equals 1. So I have 1 over 1, which equals 1. Made it, and everything else is next week. Thank you so much for your patience, everyone.